In this series, we're going over every hard advanced math question on the SAT. This is part 2, going over nonlinear functions. In this video, we'll be doing questions 23 through 44 from the online question bank. When I say 23 through 44, we're just talking about when you populate all of the hard questions under the domain advanced math and the skill nonlinear functions with a difficulty level of 3, then it will provide them in a specific order. If you download all of those, there are 88 questions. This is starting from the 23rd of those sequentially, going to the 44th. If you look up here in the top left, each question has a unique question ID. Now, if you look in the video description, I've listed all of those question IDs along with a timestamp of the exact minute and second where I start going over that problem so you can quickly navigate to find it. And I have a short description of the topic of each problem. So you could search by topic or by question ID for specific problems. This one says, a quadratic function models a projectile's height in meters above the ground in terms of the time in seconds after it was launched. The model estimates that the projectile was launched from an initial height, so it's the starting height of 7 meters above the ground, and reached a maximum height of 51.1 meters above the ground 3 seconds after the launch. So after 3 seconds passed, it moved from 7 meters to 51.1 meters. How many seconds after the launch does the model estimate that the projectile will return to a height of 7 meters? We know that with projectile motion, it's going to follow a parabola. So that will be a parabolic path, which could be modeled by a quadratic function. Now, we don't actually have to come up with a quadratic function from this. It doesn't even say if it's at Earth, so we couldn't even estimate the gravity or anything. But what we know about parabolas and about quadratic functions is that they are symmetrical with respect to the axis of symmetry. The axis of symmetry will be going through the vertex, and it's going to be a vertical line, at least for a standard quadratic like this, where it would be y equals x squared or some variation of that. So we know that at 3 seconds, it reaches that vertex. So it reaches that vertex where the height is 51.1. At 0 seconds, so at the initial time, that's at time 0, it was at 7 meters, which means that the next time it reaches 7 meters will be the same distance away from the vertex in the x direction. So from 0 to 3 is 3. From 3 to this next time that it's going to pass through will be 3 plus 3 is 6. Right, so it'll be 6 seconds after, it will be 7 meters off the ground again. Right, so 6 seconds is our answer here. And that's what they're looking for. How many seconds after the launch? So not after it reached the peak, it's 3 more seconds after it reached the peak. But from the launch, it was 6 seconds. Again, we just are using the fact that it's symmetrical to do this problem. All right, here we have y equals x squared minus 14x plus 22. The given equation relates the variables x and y. For what value of x does the value of y reach its minimum? So we want to find when is y reaching a minimum, which in this case, since it's a quadratic function, they're probably looking for the vertex. We can see it's a positive quadratic, where the a value is just 1, positive 1, which means that it's going to make a smiley face. I always would tell my students, remember that a positive quadratic looks like a smile, like a positive attitude. And a negative quadratic, if it has a negative a value, then it will be a frown. In this case, it will be this smile. So we need to figure out what's the x value that will make it reach that minimum value of y. We don't even need to know what the minimum value of y is. We just need to know what value of x will cause that. All right, and again, this is going to be something with the axis of symmetry. That would be, to me, the easiest way to solve this, unless you're just typing it into your calculator. We would say, all right, well, the axis of symmetry for a quadratic, if it's written in standard form, which standard form is ax squared plus bx plus c, that's equal to y, right, in this case, or it could be f of x, in this case it is y. So the axis of symmetry, which is, again, that line that's going to pass through the vertex, the vertical line passing through the vertex that's cutting the quadratic exactly in half, that parabola will be like have points that are equidistant from it on either side, the entire way up the parabola, extending on until infinity. The equation for the axis of symmetry will be x equals negative b, again using this b from the standard form, over 2a, which one way that you can remember that, I kept saying the last one, oh, this is something that you should remember. Make sure you look at it before. Sometimes people would mix it up. I would see some of my students write like negative a over 2b or something like that. But as long as you know the quadratic formula, or at least you would know the song for that, x equals negative b plus or minus square root of b squared minus 4ac all over 2a. Think of it, here we've got the axis of symmetry, negative b over 2a, and you're either adding the the discriminant, so the square root of b squared minus 4ac, or are you subtracting that discriminant? And the adding or subtracting is just basically to get from the axis of symmetry to those points where it happens to cross when x is equal to 0, or when y is equal to 0, because the quadratic formula is used to find the zeros of the function. So when would the output, the y value, be 0? Which again, we don't worry about that, but I'm just saying if you know that song, then you can remember, okay, negative b over 2a, that's the part that we always have. You're just not doing the plus or minus part. All right, so x equals negative b over 2a. As we said for this problem, the a value will be 1. The b value will be the coefficient in front of the x term, which is in this case negative 14. So b equals negative 14. C we don't actually need for finding the axis of symmetry, but the c would be 22. That's just going to be this constant value here. So if we plug in our b value, that would be x equals negative 14. And I'm just putting that in parentheses. I usually, when you plug something in, it's a good habit to put it in parentheses so that if there's something you have to distribute, then you'll remember to distribute, but it doesn't really matter so much here. And then that's divided by 2 times a. Our a value is 1. So we get negative 14, which is just positive 14, over 2 times 1 is 2. 14 over 2 will give us 7. So this one, the answer is x equals 7. Again, we don't even need to figure out what the y value is. They're just saying, what's the x value that will make it reach that minimum? That's 7. And for these, since you do get Desmos, the way to check it, or this is how a lot of students would probably just do it right from the get-go, although if you know to do this quickly, you could probably actually do it faster than most people could type into Desmos. But we can go to Desmos, type in our equation, y equals x squared minus 14x plus 22. So we had y equals x squared minus 14x plus 22. And the plus 22 won't actually affect where that is. But we look here, 7 comma negative 27. So that's the minimum point. The y value of the minimum point is negative 27. Again, we didn't need that. All we needed was this x value, which again is 7. All right, a park ranger hung squirrel houses, each in the shape of a right rectangular prism for fox squirrels. Each house has a height of 11 inches. The length of each house's base is x inches, which is 1 inch more than the width of the house's base. Which function v gives the volume, so we want the volume of each house in cubic inches in terms of the length of the house's base. All right, so I guess x is the length, like they said, and it is a right rectangular prism. So to find this volume of a right rectangular prism, so that volume will just be equal to the length times the width times the height. Now we can plug in those values. So for the height they gave it to us, it's 11 inches. The base has a length of x, and it says that is 1 inch more than the width. If you want to find the width, you take that extra inch away, so it'd be x minus 1. We have x inches, x minus 1 inches, and 11 inches as our 3 dimensions. So if we plug that in, it'd be the volume is equal to x times the quantity x minus 1. You have to multiply x by that entire thing, the x minus 1, times 11. All right, so I'm going to start by just distributing this x to both terms here, and that gives me that the volume is equal to x squared minus x. And I'm still keeping this in parentheses because the entire thing is also being multiplied by 11. You can't just do the second part or something like that. So now, I guess what I could have done, this might have been the better way to keep track of it. You could have just written 11x times x minus 1, and then right from the get-go to distribute the 11x, but it's the same thing. I guess I just added an unnecessary multiplication step here, but it doesn't matter so much. That gives us that the volume is equal to 11 times x squared is 11x squared, and 11 times negative x will be minus 11x. Right? So we've got volume equals 11x squared minus 11x. Oh, they don't have that as the option. So they left it where you're multiplying it by the x minus 1 still. All right, so we just basically need to find something that's equivalent to x times the quantity x minus 1 times 11, which it looks like would be option A. We have 11x times the quantity x minus 1. All right, just with the commutative property of multiplication, it doesn't matter what order you multiply these terms, as long as you're multiplying all of them ultimately. So 11 times x times the quantity x minus 1. So it'll be A. The function f is defined by f of x equals negative a to the x power plus b, where a and b are constants. In the xy plane, the graph of y equals f of x minus 15. So you're just taking that f of x and shifting it down 15. Or you could say you're translating it down 15 units, has a y-intercept at 0, negative 99 over 7. The product of a and b is 65 over 7. what is the value of A? So we're just trying to figure out what A is, which makes me think we can probably find B and then use this product to figure out what A is, right? Because if you know what B is, you plug it in and then just basically you're dividing 65/7 by that B value to get A. So first, let's see the y-intercept. When they give us the y-intercept, that means that's when x is equal to 0. Right? The x-intercept is when y is 0. The y-intercept is when x equals 0. If you ever get confused by that, just draw out your axes. So the x-axis, the y-axis. The y-intercept is where it crosses the y-axis. So on the y-axis, the y value could be anything, right? It can go all the way up to infinity, all the way down to negative infinity. It could be 0, anything in between those. But the y-axis is not to the left or to the right of the origin, right? You're only moving up or down if you do move at all. So that means that the x value does not change. So the x has to stay at 0. Same thing, the opposite, I guess, for the x-axis. If it's the x-intercept, it's where it crosses the x-axis. So the x value can change, right? It can move left and right, but it can't move up and down in that case. That's why the x-intercept is when y equals 0. In this case, they gave us the y-intercept. Also, we have the point there, so we just plug it in. So we plug it into our equation, and this is for this thing with the minus 15. So if I rewrite it all out, it's negative a to the x plus b, and then we have this minus 15 tacked down at the end. That's equal to y. So if I plug in 0 for x, it would give us negative a to, instead of the x, to the 0 power, plus b minus 15 is equal to, and our y value is negative 99/7. So now we know with our 0 power rule, anything raised to the 0 power is 1. Now, because this negative is not included with the a, right? It's not parentheses negative a to the 0 power. Only the a part is being raised to the 0 power. The negative stays out front. So instead of this becoming, you think, oh, negative 1 to the 0 power is also 1. That's true. But in this case, again, the negative is not being raised to that 0 power. So the negative stays out front. It'll be negative, and then a to the 0 is 1. So negative 1 plus b minus 15 is equal to this negative 99/7. Now we just quickly simplify this. So it's b, instead of minus 1 and minus 15, it'll just be b minus 16. It's equal to negative 99/7. Then to get b alone, we add 16 to both sides. That gives us that b is equal to, and I guess 16 times 7, that'd be 70 plus 42, which would be 112. So 112 sevenths minus 99 sevenths. You can also just type this in your calculator. But let's see, 112 minus 99 would be 13. So we end up with b is equal to 13 sevenths. All right, so if b is 13 sevenths, and we know that the product of a and b, so if I write that out, that's b times a, product means you're multiplying, is equal to 65/7. Now we can plug in this value of b we just solved for the b in this product function, and it gives us 13 sevenths times a, or 13 sevenths a, is equal to 65 sevenths. And now to get rid of the times 13 sevenths, just get the a alone, we'd multiply by the reciprocal. So times 7/13 on both sides. Right, whatever you multiply one side of the equation by, you have to multiply the other. And then our sevens will cancel out. 7 divided by 7 is 1. 13 divided by 13 cancels on this left side. It gives us a is equal to, and over on the right side, sevens cancel as well. 7 divided by 7 is 1. And 65 divided by 13 will be 5. Right? Think of that as it's 50 plus 15. So 5 times 10 is 50. 3 times 5 is 15. So a will be equal to 5. And again, that's what we're looking for. What's the value of a? So we can enter that in as our answer. I guess let me just, so it's not confusing, erase the circle around this b. I'm just plugging this value in for the b in the second equation. But our answer is the 5. Now, if they wanted a, b as an ordered pair, it'd be 5, 13 sevenths. But all they want is the a. The function g is defined by g of x equals the quantity x plus 14 times the quantity t minus x, where t is a constant. In the xy plane, the graph of y equals g of x, so y equals this function we just read, passes through the point 24, 0. What is the value of g of 0? So that means when you enter in 0 for x, what will be your output? We know when you enter in 24 for x, then your output is 0. So first, let's plug in this ordered pair that we have. So when x is 24, the output is 0 into this g function. So we'd say g of 0 is equal to the quantity x plus 14 times the quantity t minus x. When x is 24, so plug in 24 for each of these x's. So instead of x plus 14, it will be 24 plus 14. Instead of t minus x, it will be t minus 24. And that will give us an output, so g of x value of 0. Right, so 0 equals the quantity 24 plus 14 times the quantity t minus 24. Now 24 plus 14 we can just combine. That will give us 38. So we get 38 times the quantity t minus 24 is equal to 0. Now you could distribute that and work from there, but think about, we're multiplying two numbers, 38 and whatever t minus 24 equals, and it's giving us 0. To multiply two numbers and have their product be 0, one of the numbers has to be equal to 0. 38 is never equal to 0. 38 is a constant. It's always equal to 38. So that means that the 0 part must be coming from this t minus 24. So we think, when is t minus 24 equal to 0? When t is equal to positive 24. 24 minus 24 is 0. So we know that t is equal to 24. Now be careful, they're not asking what's the value of t, they're asking what's the value of g of 0. Well, we can plug in 0 for x, and now we know that 24 is the value of t. So we'll take that g function, so it's g of x is equal to the quantity x plus 14 times the quantity, instead of t minus x, let's put in our value of t, 24 minus x. And now we can just plug in 0 for x, so g of 0 is equal to the quantity 0 plus 14 times the quantity 24 minus 0. 0 plus 14 is 14. So you get 14 times 24 minus 0 is 24. So 14 times 24 will be what we're looking for, g of 0. And you can just type that in your calculator, or what I would do, let's see, 10 times 24 is 240, plus 4 times 24, that's like 4 days, would be 96. All right, so 240 plus 96 is equal to 336. So g of 0 is equal to 336. And again, that's what we're looking for. What's the value of g of 0? So our answer will be 336. That's what you should enter in. The area of a rectangular banner is 2,661 square inches. The banner's length, x, in inches, is 24 inches longer than its width. So just quickly, if we draw this banner, we could say the length is x, and that's 24 inches longer than the width. So the width would be 24 less than x, so x minus 24. You could also, if you wanted to do w, it would be w and w plus 24, but it looks like our answers use that x. And again, we're doing this in inches. If you want to do your units, just keep track. They're not, I don't think they're going to switch up on here and make us answer in feet or anything like that, but I guess it's a good habit to get into, especially if you're going to be taking physics. Which equation represents this situation? We know that the area is 2,661, and the area of a rectangle is just the length times the width. So in this case, area is equal to length times width. Our area will be equal to our length, which is x, times our width, which is x minus 24. And again, they gave us that area that's equal to 2,661. All right, so let's do our distributive property here. So x gets distributed to the x and to the minus 24. That gives us x squared minus 24x, and this is still equal to 2,661. Now it looks like the answer choices have it set equal to 0. So to get 0 on this left side, instead of 2,661, we just subtract 2,661 from both sides, and that gives us that 0 is equal to x squared minus 24x minus 2,661. All right, so we just want something like that. Looks like A is exactly that. B has it plus the 2661. C, instead of minus 24x, it's plus 24x, same thing with D. All right, so A will be our answer there, and that would be how you do that. F of x is equal to the quantity x minus 14 times the quantity x plus 19. The function f is defined by the given equation. For what value of x does f of x reach its minimum? Okay, so this one, it's another quadratic function. Hopefully you'll get to a point where you can recognize it's quadratic, just the fact if you did FOIL this out or do the distributive property, you'll end up with an x squared term, right? F of x equals x squared, there's no x cubed, anything like that. So, even without actually getting it into that standard form, you should be able to see, oh, this is a quadratic function. This is in factored form, right? And that tells us that when they ask for the minimum, which in this case, our a value will be positive because we have x times x, that's just x squared. So our a value is 1. So it will be a positive quadratic, which means, right, it's a smiley face, which has a minimum. Right, so the minimum is just going to be the vertex. And from that, we could do the vertex is when it passes through the axis of symmetry. So the x equals negative b over 2a, as we talked about in, I think that was the first problem. You could plug it into Desmos and see where it crosses that. You could figure out the zeros, and the zeros will tell you that the axis of symmetry is halfway between those two zeros. The axis of symmetry, it's symmetrical, so equidistant from the zeros, or any point, like if you share a y value, it's going to be equally far away or close to that axis of symmetry. Or we could do, in the previous video I did somewhere, I did the derivative of this function. That would be easier if it's in standard form. And then set the derivative equal to 0, because at a minimum or a maximum point where it goes from going down to going up, the rate of change is at that moment, it's instantaneously going to be 0. So at that minimum, you could set that equal to 0, find the x value that way. So again, we're looking for what value of x does f of x reach the minimum. We don't actually need to know what the minimum is. We just need to know what x value. So this one, I'm going to, because it's in factored form, I'll just do it the way where you find the axis of symmetry using the two zeros. So for this one, the zeros would be when the function is equal to 0. So 0 is equal to x minus 14, or the quantity x minus 14, times the quantity x plus 19. And just think, when is x minus 14 equal to 0? When x equals 14. Right? 14 minus 14 is 0. And when is x plus 19 equal to 0? When x equals negative 19. And the reason one of them has to be 0, you're multiplying two numbers, their product is 0, so one of the numbers has to be 0 to make that true. All right, so these are the two values, x equals 14, x equals negative 19, where the y value is 0. And that helps us because, again, we know that the axis of symmetry, which passes through the vertex, is going to be the midpoint of those two zeros. So 14 and negative 19, we know already that that's going to be a negative number because negative 19 is bigger than 14. So the midpoint is going to be to the left of the y-axis. But to find the average of those two, we could think, what do you have to add to negative 19 to get 14, which would be plus 19 and plus 14 gives us plus 33. And then just add half of 33, so 33 halves to the negative 19. That works. Oh, it looks like they're trying to trick you there with this minus 33 halves, because they're doing, that's the half of the distance between them, but we want to find what's halfway between them. Or you could just add the two numbers together, so negative 19 plus 14, and then make sure you divide by 2. The midpoint you do have to divide by 2. So negative 19 plus 14 gives us negative 5, and then if you divide that by 2, it's negative 5 halves, which is choice D. Right? And actually, right from the get-go, you could go, okay, well, it's not going to be negative 19, because the midpoint is not negative 19. It's not going to be negative 266. That's way over that way. Right? That is in no way going to be the axis of symmetry. Right? We know the axis of symmetry is somewhere around there. Right? We figured out it's actually negative 2.5 for the x value. What I'm guessing, maybe the negative 266, maybe if you plug that in, maybe that's the y value of it. That looks like, yeah, that looks plausible actually looking at the numbers there. But again, they're not asking for the f of x value. They're saying for what value of x. So read really carefully. You don't want to do all of the work or understand the problem, but then get it wrong because you just were rushing, didn't read it closely. And then from there, all you have to do is figure out which of these it is. I mean, negative 33 over 2, you could tell that's going to be way closer to the negative 19 than the 14. We want something that's halfway between the two. You could also just type this into Desmos. I'll show that in this case, that might have been faster. I mean, I was explaining all of the steps and stuff, so if I was doing this myself, I might have really quickly gotten to the 14 and negative 19, then you just do the average of those. You could even do the average on the calculator if you want. But I'm going to show how you could do it on Desmos. You just type in f of x equals the quantity x minus 14 times the quantity x plus 19. Or I guess you could just do it as y equals. I don't think there's really an easy way to type f of x, but that's just in place of that. X minus 14 times the quantity x plus 19. That. You zoom out, you can see the function. Now, I mean, you could go all the way down to the vertex like that. Just see it's at negative 2.5 comma negative 272.25. So it wasn't even exactly negative 272. And then you just have to figure out which of those is equal to negative 2.5. Negative 5 halves is equal to that. The functions f and g are defined by the given equations. So f is f of x equals 3 plus the absolute value of 2. So the f function, f of x equals 3 plus, this is the absolute value of negative 2x minus x squared and absolute value. And this g function, we have g of w is just the input here, is equal to the absolute value of, the numerator is negative w over the denominator is w minus 1 and absolute value minus w plus 5. If f of negative 4 equals c, where c is a constant, what is the value of g of c? So it looks like first we just have to figure out what c is by plugging in -4 for x in that first function. So we'd say f of -4 is equal to 3 plus absolute value of -2 times, instead of x, we're going to write times -4, minus, instead of x squared, it'll be -4 squared, and then end absolute value. Absolute value, hopefully we know that that means it's just the distance that number is from 0. So essentially, if it's negative, you make it positive. If it's positive, it stays positive. Right? So just the positive difference between the number and 0. First, let's do -2 times -4, which gives us 8. So absolute value of 8 minus and -4 squared. Even if it's a negative number squared, negative times a negative makes a positive, so it will be positive. So it's 8 minus 16. Let me just do the absolute value signs in purple so that they don't look like ones. I know that one I just drew it a little bit too small maybe, but we get -2 times -4, negative times a negative is positive, so it's positive 8 minus -4 squared is 16. And again, we still have this 3 plus that out front. So f of -4 is equal to 3 plus the absolute value of 8 minus 16. 8 minus 16 is -8. So we're getting the absolute value of -8 here. And that's getting combined with 3. You're adding 3 to it. And again, the absolute value, just if it's a negative number, it becomes positive. If it's positive, it stays positive. It's the distance from 0. -8 is 8 away from 0. So that's equal to 3 plus positive 8. So f of -4 is equal to 3 plus 8, which is 11. Right, so f of -4 is 11. And we said f of -4 is c, so that means that c is equal to 11. Right, that's not our answer. We need to now plug in c, the c value 11, for the g function. Right, it's going in as the w of the g function. So we have g of c in place of the w is equal to the absolute value of, instead of -w, we're going to write -c over, instead of w minus 1, it'll be c minus 1, and absolute value minus, and then our c value plus 5. Right, so this is what we're doing. And I guess since we already knew what c was, I don't know why I kept saying c instead of 11, but we'll just plug in 11 here. So instead of -c, it's -11. It's going to be 11 minus 1, and then minus 11 out here. And now we just simplify this. So we get 11 minus 1 is 10. So it's the absolute value of -11 over 10. And I guess I'll do the absolute value symbols again in purple so it doesn't get confused there, it doesn't get muddled. -11 plus 5. I mean, you can think of that as adding -11 and then adding 5. So the commutative property doesn't matter if we add it with this part first. I'll just combine those. So -11 plus 5 is going to be -6. So we're adding -6 to it. You know, some people get confused with that. Like, you can't do minus and then like minus 16, right? You can't combine the 11 and 5 that way. But if you treat this as plus -11, right, that's what we could do. So plus -6 now. And then that means that g of 11 is equal to this. And the negative sign will just get rid of that because the absolute value of a negative becomes positive. And if it was positive, it would stay positive. So this is just the same as 11 tenths minus 6. So g of 11, which is g of c, is equal to 11 tenths minus 6. And then if we get those to have the same denominator, we'll multiply -6 by 10 over 10, right, which is equal to 1. It doesn't change the value. You can multiply anything by 1, it stays the same. But it will just give us a common denominator. So we'll get 11 tenths minus, and that would be 60 tenths. So 11, which, or I guess we can even combine those because they have the same denominator. So it's 11 minus 60 all over 10. And 11 minus 60 is equal to -49. So we get -49 over 10. Right? And that does make sense. You might think, oh, well, you can't have a negative answer if there's an absolute value. But the absolute value is not over the final answer. The absolute value is within this function, and then you're subtracting something outside of that. Right? And we're subtracting something 6 that's bigger than the thing inside of the absolute value function. All right, so -49 over 10, you can write it like that. That is fully simplified. 49 is 7 times 7. 10 doesn't have any 7s in it as factors. So that answer is acceptable. Or if you want to put it as a decimal, right, dividing by 10, you just move the decimal place over 1, so it'd be -4.9. Right? Either of those answers should be acceptable. The function f gives the product of a number x, so product means we're multiplying, and a number that is 91 more than x. So we could just say 91 more is 91 plus x. So we're multiplying x and the quantity 91 plus x. Which equation defines f? All right, well, f of x is the product of these. So x times something 91 more than x. And now it looks like they distributed here. So we're just distributing x to the 91 and to the x. That gives us 91x plus x times x is x squared. So f of x equals 91x plus x squared, or the commutative property of addition, doesn't matter what order we add those things, it could be x squared plus 91x. Right, so either of those would be acceptable. Let's see, it looks like C is our answer here. All right, I'm not sure why this one's in the hard section. I guess you have to read what this part says and you have to know what product means, but I would definitely put this one at least in the medium, if not the easy, compared to some of the other ones we're doing. All right, this one has m sups, which means we might not be able to figure out what the answer is. Yeah, it looks like A and B appear the same as C and D. M sup just means that they have some error with loading in the answer choices. Maybe we could figure out what the answer is so that we would know, like, if they do fill it in eventually, then you could figure that out. But let's see. So a model estimates that at the end of each year from 2015 to 2020, the number of squirrels in a population was 150% more than the number of squirrels in the population at the end of the previous year. So it's 150% more. So for a second I thought that meant we're just adding 50%, but no, you're actually adding 150%. So it's 2.5 times the population of the previous year. Right, think about it. You already have 100% of what you had, and then you're adding 150, so it's going to be 2.5 or 250% of that. If you multiply it by 2.5. If you're figuring out what you're adding, then you're adding 1.5x to x, or whatever you had. The model estimates that at the end of 2016, so the end of 2016, there were 180 squirrels in the population. Which of the following equations represents this model where n is the estimated number of squirrels in the population t years after the end of 2015? So that means that this is when t equals 1. T is 1, the output, the number of squirrels, n, is 180. So first we need to figure out what t of 0 is. This is exponential growth, right? You're multiplying it by 2.5 every year. And again, think about how I got that 2.5. We're adding 150% to 100%. So we're multiplying it by 2.5 times, right? 250%. And t is less than or equal to, what is a 5? I mean, that's just because the model only works until 2020. I don't know, were the squirrels affected by COVID or something? Or maybe it's just, at that point, it stopped being exponential growth, or that same degree of exponential growth. Maybe it got so close to the carrying capacity, or some other predator came in, or just, again, maybe COVID actually did affect it, because something about people not being as present there, who knows. Our function would be, I'll just write f of x, or let's do the squirrel function, so maybe q for squirrel. Oh no, it's n. So n of t is equal to, and let's see, we don't know what our starting value was, our principal amount. That would be at time 0, how many squirrels there were? So at the end of 2015. But so that would be a for now. A times b to the x power, or t power, right? T is what we're inputting as our variable here. So a times b to the t would be our exponential function here. Our b value, we actually know, like we said, that's going to be 2.5. Right? That's just the growth factor, what you're multiplying it by each year. If it grows by 150%, that's 1 plus 1.5 is 2.5. So we have n is equal to a times 2.5 to the t power. Now we could plug in the value we know, which is when at the end of 2016, there were 180 squirrels. That's our n value. We still don't know the a value. The a value we still need to solve for, but that would be a times 2.5 to our t value would be 1. It's 1 year after 2015, or the end of 2015. So 2.5 to the first power is just 2.5. That gives us 180 is equal to 2.5a. And now to figure out what a is, we just divide both sides by 2.5, the opposite of times 2.5. That gives us that a is equal to, let's see, 180 over 2.5. We could think of this as 1800 over 25, and then just divide that by 5 twice. So divided by 5, that's 20%. So it'd be, what is that, 360 over 5, and then 360 divided by 5 is equal to 72. You also type that in your calculator. 72 times 2.5 should be equal to 180. That does make sense. 72 times 2 would be 144, and then add half of 72, add 36, gives you 180. So a is equal to 72, which means I'm assuming you can get rid of c and d. Again, the real thing, they would give you the entire function. But we just plug in this 72 for the a value of this function we already wrote. So n is equal to a, which is 72, times b, which we said was 2.5, to the t power. And only the 2.5 part is being raised to the t power. They might write it like this. They might just put the t over it, because exponents come before multiplication anyway, so that would be clear. But whichever option is equal to that would be your correct answer. Just make sure that you're really comfortable with exponential functions, and particular growth factors, because what I'm assuming is probably one of these, instead of 2.5, did 1.5 to the t, like that. Just be careful right? The growth factor, you keep the 100% you already have plus however much it grew, right? And always read carefully. Are they saying it's a 150% more or 150% of? Of means you're multiplying it by that. So that would just be giving you the growth factor, right? So it's 250% of the previous year. It's 150% more. All right, here we have f of x equals the absolute value of 59 minus 2x. So of that entire thing there. The function f is defined by the given equation. So this equation up here. For which of the following values of k does f of k equal 3k? This one's interesting because there's not one correct answer. If there weren't options, there wouldn't be a way to answer this. It's saying which of these options makes this true, because there could be potentially multiple. But here we're just choosing one of them. We could just plug them all in and compare them to 3 times that number. What is the k value? What is f of k? What is 3k? I'm gonna make a little table here. So for option A, k is 59 fits. F of k would be 59 minus 2 times 59 fits. 59 times 5 fits minus 2 times 59 fits, which is 3 times 59 fits. So the absolute value of that is 3 times 59 fits, which is triple it. We don't even need to figure out what 3 times 59 is. 3 times k is 3 times 59 fits. So it seems like that's the answer. Guess we could continue filling out the table, just make sure none of the other ones is true of that. The SAT only gives actual multiple choice options. They don't give where you have multiple answers that are correct. So this is mostly just to check. But we could say B, 59 halves. So if you subtracted double that, that'd be 59 minus 59 halves times 2, which is just 59. So 59 minus 59 give you 0. The absolute value of 0 is still 0. Right? It's how far away is it from 0? 0 away from itself. And that's not equal to 3 times 59 over 2. So we know it's not B. We already knew it was A, but all right, we weren't able to find an error where they have 2 different correct answers. And then here we have 177 fits. Well, for this, it'd be, you'd do the same thing, 59 times 5 over 5 minus 177 over 5. And that's not going to be equal to 3 times itself, but I guess now we might have to actually figure out what 59 times 5 is. That would be, let's see, 250 plus 45 is 295. So 295 fits minus 177 fits. It's the absolute value of that. I mean, the absolute values aren't really mattering for any of these so far. It probably will for D. But for A, B, and C, it was already a positive number in there. Let's see. So 295 minus 177 would give us 118. So 118 fits, which is not equal to triple 177 fits. So these are not equal, not equal. This one was equal. So it's not C. And then lastly, D, let's see, it would be 59. So if you subtract 59 minus 2 times 59, if you subtract double something from itself, it will just give you the negative of that answer. This is the absolute value of negative 59, which equals 59. So that's equal to k, but we want the one that's equal to 3 times k. So 3 times 59, which is not 59. 59 is not equal to 3 times itself. So it's not D either. All right, on this real one, after I got A, I would just be really happy that it happened to be the right answer and probably move on. Maybe put a star next to it so you'd know to come back and check the other ones as well. Now, I guess I'll show how you could use Decimus to potentially speed this up. I mean, this wasn't really that fast. Again, if you just stopped right when you figured out that A was right, then this took no time at all, as long as you did the math right. But, maybe you're not super comfortable with fractions. Here's what you could do. So you could go y equals the absolute value of 59 minus 2x. Okay, so we've got this. Absolute value functions. They look just like a line, except then once they reach this bottom point, it goes back up. So it makes like a V shape. And we would just figure out, all right, well, what were our options? We had 59 fits. So we would just say that's equal to x. So x equals 59 fits, right? It'd be that. And then you'd go, okay, what's 59 fits times 3? 35.4. 35.4 is the output of this function. Okay, so you could compare them that way. Oh, they're both the same. Or for one of the other ones, for 59, we could say x equals 59. That crosses here at 59 comma 59. And then hopefully you know that that's not equal to 3 times 59. But again, if you wanted to figure that out, just 3 times 59 on here, 177. Oh, that's not equal to 177. All right, so this is just one way that you could do it. I think they had 59 halves. So again, we do x equals 59 halves. And then you could see, oh, that crosses at x equals 0. We also know, again, without typing that in, you probably know 59 halves times 3 is not equal to 0. And then I think the last one was 177 fits. So 177 fits is equal to x. crosses there at 11.8, which is not equal to 177 fits times 3, which again, you can just verify like that. That should be 106.2. It's way less than that. So the only one that this works for is A, 59 fits. Gives you an output of 35.4, which is also 59 fits times 3. So I guess both of those would probably be equally quick. I would probably just do it this algebraic way, but if you're not super comfortable with fractions, if you think you might mess up some of this math, or even if you're not comfortable with absolute values. Now, the Desmos calculator does have an absolute value thing built into it. Some students, if they have a calculator that doesn't do absolute value, what you can do is square root of that thing squared. Because think about 59 minus 2x squared. Even if this is negative, if you square something, it becomes positive. And then square root only gives you the positive square root of that thing. So this is the same thing as an absolute value function. So if you ever have a calculator that you can't do absolute value on, or you don't know how to do absolute value, then just do the square root of the whole thing in parentheses squared. We'll do the same thing. All right, I have another M-sup one here. Well, maybe this one we can figure out which of the answer choices it wants it to be. Again, I always will try to write what the actual answer should be so that you'll know in case they end up updating it eventually, or just if you get a problem like this. So we have the function f is defined by the given equation. The given equation is f of t equals 55t minus 2t squared. The function g is defined by g of t equals f of t, so this original function, plus 3. So we're just shifting it up by 3, or translating it up 3. Which expression represents the maximum value of g of t? So when they say the maximum value of g of t, they mean the output. It doesn't say what value of x does it give you a maximum value of g of t. What value of g of t is the maximum? So basically the y value of that vertex, assuming that it's a negative quadratic, which it is because our a value is -2 here. Right? It will even be -2 when you add 3 to it. So if our a value is negative, that's going to be a frown. It's a negative parabola, which does have a maximum point for the vertex. For this one, we do need to figure out the vertex, and you can't just do like axis of symmetry or setting the derivative equal to 0 or something. You can't just solve for the x value. You need to then plug that x value in of the axis of symmetry and figure out what the output is for that x value. All right, so we could do it that way. In this case, I probably would just use Desmos. Just make sure you don't forget this +3. That's what they're trying to trick you with here, is the +3 part. They think someone's going to forget to put that in, and then they'll just choose the answer that doesn't have that. Although all the answer choices have this 3 plus, which expression represents the maximum value. That's interesting. You don't actually find the point. You see, you just have to find the expression that's equivalent to it. Because you could find the actual point in this case. That's weird. Oh, I guess they're trying to discourage you from using Desmos. All right, so I will just show you how to do it algebraically then. And maybe I'll show you two different ways. So first, let's write out what this g function is. So g of t is equal to our f function, which is 55t minus 2t squared plus 3. Now, I'm going to rearrange this just really quickly. Generally, the commutative property of addition doesn't matter what order you add them, but generally you're going to put the x squared or the t squared term first, and then this is plus 55t. So -2t squared plus 55t plus 3. Doesn't really matter, but I guess if you're trying to figure out the a, b, and c values, then you're not going to mess it up. So if we want to do it using the axis of symmetry, we'd say x is equal to -b over 2a. Now our b value is 55, and our a value is -2. C would be 3. We don't need that for this. So that gives us x is equal to -55 all over 2 times our a value is -2. All right, so -55 over, this is going to be -4. The negatives will cancel out, which gives us that x is equal to 55 fourths. So 55 fourths is our x value. That's not your answer, so don't choose an answer choice that's equivalent to that. What we need to do now is plug this x value in for t, or I guess, yeah, it should be t is equal to, basically its input is equal to -b over 2a, so this is t in this case. But we just plug that in for the input, so we'd find g of 55 over 4, because this is the x-coordinate of the vertex. Right? The axis of symmetry will always pass through the vertex of a quadratic function. So we have g of 55 fourths, which is equal to -2 times 55 fourths squared, plus 55 times 55 fourths, plus 3. So what I'm guessing, this would be the answer. If you type this all in, it will give you the actual answer, which normally you would do. I guess normally what you do is just type it into Desmos, see what the y-coordinate is of that. But what we can do is just write out 3 plus, and then it looks like, I'm really curious what the m-subs would be. You could do 3 plus and then this whole thing, which might end up looking like 3 minus 2 times 55 fourths squared plus 55 times 55 fourths. Right, that would be an acceptable answer. I don't know if the m-sub would be that long, or do they want the entire thing in a -2? Then it could be 3 minus 2 times, and then I guess you'd have to factor a -2 out of each of these. So this would be 55 fourths squared minus, and then 2 out of this would be 55 times 55 over 8. Right? The positive becomes negative because you divide it by -2, and then you're also taking a 2 out of 55 fourths becomes 55 eighths. So that would be an acceptable answer. I don't know if they have it in terms of the x's or something still, or the t's, but that would be how you would do this. Ultimately, we're just trying to figure out what is that vertex value. And if they do have numbers here, I mean, that's the other thing. They might leave it in terms of t. That'd be kind of weird, though, because it doesn't say t is equal to this. But if they do give you numbers, so if they give you something like this, then what you can do is just graph it, find what that vertex is on Desmos, and then type all of these options in and see which one is equivalent to the y-coordinate of the vertex. But my guess is it's probably going to be this one. It could be D. It could even be A. I guess you could be adding this 55 times 55 fourths, something like that. But I don't know. This is kind of a weird problem to ask it this way. But I can see what they're doing. They're really trying to discourage, just trying to make it difficult to type it into Desmos without understanding what's going on with the problem. The population P of a certain city Y years after the last census is modeled by the equation below, where R is a constant and P of 0, that's probably the population at time 0, is the population when Y equals 0. Is Y is the input in this case. Usually we use Y as the output. Okay, but Y is our input here. If during this time the population of the city decreases by a fixed % each year, which of the following must be true? Okay, well, if it's decreasing, that's decay. Decreasing each time. So anytime you multiply it by this 1 plus R, it's going down. That tells us that 1 plus R has to be less than 1. Right? For it to be decaying, then you're multiplying it by something between 0 and 1. Right? Exclusive. So it's getting smaller. Even if you're multiplying it by 0.99, then it's getting 1% smaller each year. So this says R is less than -1. No, we want 1 plus R to be less than 1. But still greater than 0. So I guess we could do subtract 1 from both sides. So -1 is less than R is less than 0. So R is something between 0 and -1. It's something that will bring 1 down. When you add it with 1, it will bring it down, but not past 0. So we don't want to make it actually negative. R is supposed to be greater than -1. But -1 is less than R is less than 0. Okay, that's literally what I just wrote. So it's B. 0 is less than R is less than 1. No, 1 plus R, right? 1 plus R has to be between 0 and 1, the actual growth factor. But the growth factor here is 1 plus R. So it's not C. R is greater than 1. No, it's not greater than 1. All right, so that would be how you do that one. This one's more just a conceptual problem, understanding what's going on with growth factors and with exponential functions. All right, here we have a graph. Looks like it's approaching some kind of asymptote at y equals -7. Just like a invisible line that it gets closer and closer to, but never crosses. Although maybe it does cross it. No, look at this. Hard to say. It might just be getting like closer and closer to a point where you can't see the distance between them. But the graph of y equals f of x is shown, where f of x equals ab the x power. So a times b to the x power plus c, and a, b, and c are all constants. For how many values of x does f of x equal 0? Doesn't look like it ever is equal to 0. All right, well, if there is an asymptote here, if there is a horizontal asymptote, then never, right? Then it's never going to actually get up to the y value being 0. But let's see. It looks like the plus c, it doesn't say the positive constant, so the plus c is probably negative. It's bringing it down. A times b to the x. Or it could just be that a is negative, and it's a negative enough that when you, and maybe it's growth. Is this growth function? It's getting bigger and bigger and bigger. But yeah, either way, it would be approaching an asymptote in this direction if it's just a standard exponential function, right? Because normally it would look like that, right? Like it would never go below 0, thinking for a normal growth function, growth curve. And this one is just inverted, right? It's flipped over the axis and then shifted. So it's more like that. And yeah, that would lead us to believe, it's never going to actually reach a y value or output value of 0. So there are 0 answers. For how many values of x is f of x equals 0? none. The function f gives the value in dollars of a certain piece of equipment after x months of use. And that function is f of x equals 5,470 times the quantity 0.64 raised to the x over 12 power. If the value of the equipment decreases each year by p% of its value the preceding year, what is the value of p? All right, so first of all, it says each year. This is x over 12. X is the number of months, which is why it's x over 12, right? Because you figure out for each month. So just when x goes up by 12, it's 12 months divided by 12 is just 1 year. So the growth factor that they have here, actually the decay factor, is already set at like for a year. So they were trying to, they're trying to make it seem like it's tricky where they have the years and months, but they already kind of set it up nicely for you. So you don't have to actually raise something to a power to figure out what the growth factor would be over that whole period. But the tricky part of this is, let's say, it says if the value of the equipment decreases each year by p%, what's the value of p? So how much is it going down by? They're not saying what is the growth or decay factor, right? The decay factor in this case would be 0.64, but that means how much is it going down from 100% or from 1? And you can just do 1 minus 0.64, which will give you 0.36. That's 36%. And we want to figure out what is the p value of that percent. 36% equals p%, so p is equal to 36. It's going down by 36. All right, so the months year part, they're trying to make it seem like that's the trick. The real trick is it's how much is it decreasing? So how much is it going down from 100%? Right? So just make sure that you're really comfortable with growth factor, decay factor, exponential growth, exponential decay, and again, how you can figure out. This would be like if you wrote 1 minus r for a decay factor to the x power or whatever, x over 12 in this case, then they're asking what is that r value. So if 1 minus r is equal to 0.64, basically what would r be? Subtract 1 from both sides, that gives you negative r equals negative 0.36, r equals 0.36. Right? That's how some students would do that. I just like to think, what did you take away from 100 to get to 64%? But either way works. The function f of x equals 1/9 times the quantity x minus 7 to the second power, or quantity x minus 7 squared, plus 3 gives a metal ball's height above the ground, f of x, in inches, x seconds after it started moving on a track, where 0 is less than or equal to x is less than or equal to 10. So this is the domain of the function. It just works between 0 and 10 inclusive. Which of the following is the best interpretation of the vertex of the graph of y equals f of x in the xy plane? So the vertex, let's say it's measuring, f of x is measuring the height above the ground. So the vertex, in this case, it's going to be, I guess it's going to be a positive quadratic, right? It's like that. The vertex, it's already in vertex form, so we can figure out what the vertex is, right? That's, you could say f of x equals a times x minus h squared plus k, and that should be the quantity x minus h squared plus k. So in this case, our a value, which doesn't really matter, is 1/9, or it doesn't matter for this problem, I'm saying, but it does matter in general. Our h value is 7, what we're subtracting from x, and our k value is 3. And h comma k is our vertex. So that would mean that our vertex is 7 comma 3. 7 is the input, which is the number of seconds. So 7 seconds after it started moving on the track, it reached a height above the ground of 3, which is the minimum. We know it's the minimum because it's a positive quadratic. Oh, the a value does matter. Okay, I was wrong. The a value being positive matters. You don't actually care that it's 1/9 versus if it's 1, but it's a positive a value, which means that it is going to be a smiley face, which does have a minimum value for the vertex. So it reaches a minimum height of 3, inches? So 3 inches above the ground at time 7. 7 seconds after it was dropped, right? 7 comma 3. So we want something that says something like that. The metal ball's minimum height was 3 inches above the ground. Okay, that seems right. I'm just going to circle that for now, but let's see. The metal ball's minimum height was 7 inches above the ground. No, 7 is the time, right? X is your time. Your height is the output, right? The f of x. So the height would be 3, not 7. The time would be 7. The metal ball's height was 3 inches above the ground when it started moving. No, when it started moving would be when x equals 0. If you want to find when x equals 0, it would be 1/9 times 0 minus 7 squared. So 1/9 times 49 plus 3, that would be the height at the beginning, the initial height. Or you could just, factor out this entire thing, get it in standard form, and then it would be your c value. C value is not the same as the k value, so it's not the plus 3. But yeah, either way, that's not going to be what the vertex represents in any case, and that's not an accurate value for the vertex. And this is going to be the same thing. We're saying that when it started moving, no. So the answer would be A. The metal ball's minimum height was 3 inches above the ground. That occurred at 7 seconds, but it doesn't include anything about that in the answer choices there. All right, we have f of t, this function f, is equal to 8,000 times the quantity 0.65 raised to the t power. So we have an exponential function. Our principal value, so the value at the start is 8,000. Our growth factor, or actually the decay factor in this case, what you're multiplying it by each time t goes up by 1 is 0.65. So it's decaying 35%. It's going down 35% from 100% to 65% each time t goes up by 1. So the given function f models the number of coupons a company sent to their customers at the end of each year, where t represents the number of years since the end of 1998. So each year from 1998 on, it seems like they're sending 35% fewer coupons than the year before. And 0 is less than or equal to t is less than or equal to 5. So it only works between the years 1998 is year 0, or time 0, and then 5 years after that would be 2003. So they stopped doing it in 2003. If y is equal to f of t is graphed in the ty plane, it's interesting, they usually say the xy plane, but we're using t instead of x here, which of the following is the best interpretation of the y-intercept of the graph in this context? So the y-intercept, that's when, usually we'd say that's when x is equal to 0, but now it's the ty plane, so it's when t equals 0. So when t is equal to 0, and now I guess we just type that in, 8,000 times 0.65 to the 0 power. Anything to the 0 power is 1, so that's equal to 8,000. So f of 0 is equal to 8,000. What is this representing? The number of coupons? So at time 0, which time 0 we said it's the year since 1998, so it's in 1998, they had sent 8,000 coupons. So we want something that says something like that. In 1998, 8,000 coupons were sent. Is that what it said? The number of coupons a company sent to their customers, where coupons were sent to their customers. So the minimum estimated number of coupons the company sent to their customers during the 5 years was, no, that's not the, I mean, that might be right. I don't even, like, we didn't find the vertex. It's not a quadratic function. So the minimum would be after 5 years. If you plug in 5 for t, I don't know if that's the value. That looks like maybe it could be right. But that's not what the y-intercept represents. The y-intercept is when the x value, or the input value, in this case it's t, is equal to 0. The minimum estimated number, it doesn't do the minimum. Actually, that would be the maximum. Right? Since it's decaying each time, then the start is the most, and it's going down each time, each year from the start. The estimated number of coupons the company sent to their customers at the end of 1998 was 1428. No, we said it was 8,000. And the estimated number of coupons the company sent to their customers at the end of 1998 was 8,000. Good. So it's D will be our answer. The other ones don't make any sense. Which of the following functions has or have a minimum value at -3? So we've got two possible functions. It could be one of them, both of them, or neither of them. It says f of x is equal to -6 times the quantity 3 raised to the x power minus 3. So we have an exponential function there that's shifted down by 3, where our principal value was -6. So, well, actually, technically, the principal value is -6 minus 3, so it'd be -9 right, at time 0. But right, the thing that you're putting there, the a value is -6. And our growth factor is 3, so it's tripling each time, or I guess coming 3 times more negative because we have that. And the other one, we have a principal value of -3. So when x is equal to 0, it would be -3. And then our growth factor is 6. Okay, so which of the following functions has a minimum value at -3? When I say at -3, that makes me think it means when the x value is -3. Because otherwise you'd say a minimum value of -3. So at -3, we could figure it out. I mean, one way you could do this is just type them into Desmos and check. I think I will show you that in a second. But first, let's see if there's a way you could do this a little bit more algebraically or just using some logic here. So minimum value, that means it's the lowest possible value. It looks like both of these, even though they are growth, right? They do have growth factors, like the b value is greater than 1. They're actually getting more negative, right? Because we have these negative a values. Right? So this first one, right, when x is equal to 0, we said our output would be -9, right? Because you'd say -6 times 3 to the 0 minus 3. 3 to 0 is 1, so it's -6 minus 3 is equal to -9. So at time 0, it's -9, which is already less than -3, although they say value at -3, okay. And then each time from there that x goes up by 1, you're just tripling that. right? So at 1, at 2, at 3, at 4, so on, right? It's going to triple that. So that would become more negative. It's going to go negative 27, and then negative 81. I know this is not drawn to scale at all. And then negative 243, and then negative 729, right? Just tripling a negative number makes it more and more negative. So the minimum value is not at 3, right? It just keeps going down and down and down, right? They didn't give a domain of this or anything. So there really is no minimum. It just keeps going. The maximum would be at, let's see, I mean, negative 3. Is the maximum negative 3? I think that's true, right? Because this could get closer and closer to 0 as it goes negative. Like negative 6 becomes smaller and smaller and smaller, approaches 0, but it's still shifted down 3. So the maximum value, it actually never hits 3, but the asymptote is at y equals 3. Are they using y here? F of x equals 3. But, I mean, for one, that's not what minimum means. It doesn't actually ever touch that point, because an asymptote, it gets closer to it without ever touching it. So we'll get to like negative 3.00000000001, and then, you know, infinitely closer than that even, but technically never touches negative 3 anyway. And it's still, that's not a minimum, right? There's no minimum. So that's 1. And 2 is the same thing, except it's just not shifted down by 3. And I mean, they also flipped them. So you're getting 6 times more negative each time. So you're starting at, when x equals 0, it's at negative 3. And this one actually does go even higher than that. This one goes all the way up to 0. It gets closer and closer to 0 is where the asymptote would be for this g function. And then it's getting 6 times. So this one's really steeply dropping, but both of them approach negative infinity, where they just keep getting more and more negative. So neither of them has a minimum value of negative 3. That would be d. I know, hopefully when you see this one, you can figure that out quickly. And you could just type them into Desmos. I guess I'll do that just to show. So it's negative 6 times 3 to the x minus 3, and negative 3 times 6 to the x. So y equals negative 3 times 6 to the x. So we said, right, our y-intercept is negative 3. It approaches 0 as the y value, and then it just keeps getting 6 times more negative every time x goes up by 1. It's going down really precipitously. That was the second equation. That was the g function. And then the first one was y equals negative 6 times 3 to the x, and then minus 3. We said, right, our y-intercept is negative 9. It's approaching negative 3. It never actually crosses negative 3, but it gets infinitely close to it. And then it's going down, right, at a slightly slower, well, not, I mean, instead of tripling how negative it is each time, the red one is going 6 times as negative each time. But, you know, neither of them has a minimum value. Neither of them has a minimum value of 3 for sure. And definitely neither of them has a minimum value of negative 3. Or was it 3? I don't even know. Negative 3. So it's neither of those. That'd be D. Again, hopefully you can do that without using Desmos. Just that would show a conceptual understanding of exponential functions, how to graph them from just looking at it. But you do get Desmos. So you might as well look at that. I don't really see how anyone would get this wrong unless they're really rushing or think that they have some trick or something. All right, in the xy plane, a parabola has vertex of 9, negative 14 and intersects the x-axis at 2 points. So it has 2 zeros. If the equation of the parabola is written in the form y equals ax squared plus bx plus c, so that's in standard form, where a, b, and c are constants, which of the following could be the value of a plus b plus c? Okay, there's an interesting problem. So I think the main thing they're getting at with this, it intersects the x-axis at 2 points. That means that the discriminant, so the discriminant is when you write out the whole quadratic formula. I sang it earlier, but that's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, that's how I learned it. I've heard people sing it different ways. The discriminant is just this thing that's under the radical here, so the thing that you're taking the square root of. And the reason that it matters, why it helps you discriminate how many answers there are, like to discern that, to figure out, oh, is this one with 0 real answers, 2 real answers, or 1 real answer, is because we know you can't do the square root of a negative number in the real number system, right? The square root of a negative would be an imaginary number, or we'd say it would be a complex solution in that case. So if we're operating in just real numbers, then we know that b squared minus 4ac would have to be positive to give you 2 solutions, right? If it's equal to 0, the square root of 0 is just 0. Adding 0 is the same as subtracting 0. That's why you would only get 1 answer. The reason that you would only get 1 0 is if the axis of symmetry is where it crosses the x-axis, right? So that would mean Right? It's reaching the vertex. The vertex is on the x-axis. So it just touches it at that one point and then immediately goes back up. Or if it's a negative quadratic, it touches it and then immediately goes back down like that. So that would be when you have 1. We just need b squared minus 4ac has to be positive. So it has to be greater than 0. Right? If it's 0, there would be only one solution. If it's a negative number, the square root of a negative, as we said, is imaginary. So you wouldn't get any real solutions. All right, so we know that b squared minus 4ac is greater than 0. That's just from this part where it says across the x-axis at 2 points. Right? We're assuming we're talking about real numbers, right? Actual points, not on like some imaginary axis. So if the equation in the parabola is written in the form y equals ax reduced to c. So now we can look at the vertex. So we know the vertex is at 9, negative 14, which means if we wrote it out in vertex form, that would be y equals a times, you'd say x minus h. So in this case, our h value is 9. So y, x minus 9 squared, and then plus k, so minus 14. So this is equal to ax squared plus bx plus c. We could also do, okay, well, our axis of symmetry would be, right, x equals negative b over 2a, and the axis of symmetry passes through the vertex. So you'd say 9 is equal to negative b over 2a, which could potentially help us as well. And then you could even plug that value 9 into this function. We could say y equals a times 9 squared, so 81a plus b times x, so b times 9 plus c, and then that would give you an output of negative 14. So those are other equations that you could use. I'm going to start with this vertex form that they give us, though, which again, I just plugged in this h comma k into the function y equals a times x minus h squared plus k, which is vertex form of a parabola. Okay, so we can factor this out. That gives us x minus 9 squared would be x squared minus 18x plus 81, like that. And we'll multiply that whole thing by a and then subtracting 14. It gives us ax squared minus 18ax plus 81a minus 14. That's equal to y. That means that the b value is negative 18a and the c value is 81a minus 14. Right? This is a constant, and then we're subtracting 14 from it to get this entire thing as a constant. All right, so we can say b is equal to negative 18a and c is equal to 81a minus 14. So if we add them all up, a plus b plus c, that gives us a plus, I'm just putting them all in terms of a's, negative 18a plus 81a minus 14. And then if you combine those, let's see, we have a minus 18 would be negative 17a plus 81a minus 14. And let's see, negative 17a plus 81a, that's like 81 minus 17 total a's. So minus 10 would be 71, minus 7 would be 64. So you get 64a minus 14 is going to be a plus b plus c. Does it say that a, b, and c are integers? No, just that they're constants. Well, this doesn't really help us, right? Well, this part here, when I plugged these in. But I think the fact that b and c have to be in this ratio to a will help us if we go back to this discriminant thing, right? Because that would be the restriction. Because they don't say what is the answer. There's not one answer. It says which of the following could be the value of a plus b plus c. So which could be the value of a plus c plus c? Well, that sounds like it's going to be something that's restricted by some inequality. This is the only inequality that we have here. And, again, we could maybe try to explore something with these, but I don't know if that would lead to anything. So let's just plug in these a values of b and c for this discriminant function, okay? So instead of b squared, I'll write negative 18a squared. Instead of minus 4ac, it'll be minus 4 times a, which a is just, a in terms of a is just itself, times c in terms of a is 81a minus 14. Let me move this over so I have a little more space. 81a minus 14, and this is all greater than 0. Okay, so now if I multiply this out, we get negative 18a squared. Negative squared is going to be positive. 18 squared is 324. So we get 324a squared. Negative 4a is getting distributed to both of these. So negative 4a times 81a and times negative 14, which gives us 324a squared minus 4 times 381 would be 324. Oh, that is 3. Oh, nice. Okay, this seems like it's going to be the answer now because those are going to cancel out the a squared values. And then we have negative 4a times the negative 14. Negative times the negative is positive. 4 times 14a will be 56a. So 56a, and then again, these 324a squared and the negative 324a squareds cancel out when you combine them. So we just get 56a is greater than 0. So 56a is greater than 0, and then 64a minus 14. Oh, this, I did say this stuff didn't matter so much, but it ultimately kind of will matter because we already have 64a minus 14 is the sum of a, b, and c in terms of a. And we know that 56a has to be bigger than 0. If that's the case, if 56 times a is greater than 0, that means the smallest that a could be. I mean, I'm thinking of just divide both sides of 56. A has to be greater than 0, right? That's the main thing there. So a could be 0.0001, but a just has to be greater than 0, right? Because the a squared parts of those cancel out. So a has to be greater than 0, and then 64a minus 14. Think about this. If you plug in 0 for that, it'd be 64 times 0 is 0. 0 minus 14 is negative 14. Okay, so that would be this one, but it has to be greater than 0. It can't be equal to 0, so we can cross that out. And if you do anything smaller than 0, so like a negative, any negative number, negative 1, negative 2, then that would be, again, violating this rule, a is greater than 0. That would be when it goes below negative 14. If you want to do any number less than negative 14 for the sum of a, b, and c, which is what this represents, then a would have to be less than 0, which it's not allowed to be. So that would be b and a. So there's no actual way to arrive at negative 12 being like a correct answer. I mean, you could figure out negative 12 could work, right? There's a way to make this equal to negative 12, where a is greater than 0. I guess we can figure out. It would be 64a equals, add 14 to both sides, gives you 2. So 64a equals 2, so that means that a is equal to 2 over 64, which is 1/32. 1/32 is greater than 0, so that's allowed, right? And then you could even plug them in, figure out what b and c are, but that would be how you do d. Okay, interesting. So this was a really fun problem. I would probably be stressing, if I did not have a lot of time to do that one when you get to the test, then I would be stressing, especially if I hadn't seen it before. But so the key things, I know I wrote a lot of stuff that I didn't end up using. So you don't need to use the vertex here. You don't need to use, what was this? I just plugged in the vertex point. What you needed is the b squared minus 4ac is greater than 0. Which, if they're giving you something like a quadratic, and they say which of the following could be the value, that tells you it's probably going to have something to do with an inequality, right? Unless it's something that you could easily plug in. This one was really mean, because they really were trying to make it so you couldn't use just decimals for it. The a plus b plus c, because, right, you can't just plug in values. If they said, like, what's the value of a, then, you could plug in different things and try to figure it out that way. But this, I just got all of them in terms of one of the other variables, which I did that by writing it in vertex form. Okay, so if you get this exact problem format, but probably with different numbers, no, you'll need to do the vertex form, and you will need to know that if there are 2 zeros, then that means the discriminant, the b squared minus 4ac, the thing that would be under the radical sign in the quadratic formula, would have to be greater than 0. So using those two things, I rewrote this. So I wrote it in vertex form, and then I expanded the vertex form. I wrote vertex form using the vertex they gave me. And then I wrote that out, so I got the b value and the c value in terms of a. Again, the c value is this entire thing, the 81a minus 14. So I wrote what the b and the c were in terms of a, that's over here. And then I plugged those in for this discriminant being greater than 0. And it gave me this restriction that a had to be greater than 0. Which I think I got lucky with it. I don't know if it's probably luck that the numbers worked out, because otherwise you would have gotten some like big ugly thing here. But they'll probably, if they're given that same kind of problem, they would make it so the numbers will work out. And it just gave me a has to be greater than 0. From there, you could figure out, I also had to plug in a, b, and c using these values of b and c that used a. So this is how I did that. And then you had to figure out what value of 64a minus 14, which is equal to a plus b plus c, works when a is greater than 0 and only negative 12. All right, so this is how I did it. It worked. It took, a decent bit of time. So I would say if you're going for a 1600, make sure that you're giving yourself time, because how the SAT works, they're giving you, that first set, which has some easy, some medium, some hard problems. If you get all of them right on that first set, then you're going to get mostly hard problems in your second set. So you're going to have to work really quickly through the other hard problems. And then when you get to one like this, it will probably take you some time. So, if you really think that you can get that 1600 based on your practice and that you're able to work quickly, this would be how you do it. And having an idea of a game plan going in, so you're not wasting time doing something with the axis of symmetry formula, or with like plugging in that value of 9 and negative 14 for the vertex. Then, again, I plugged them in vertex form, but I didn't just plug it into the equation for x and y. Then that would help you to get there, all right? But I think what I would recommend for this, so make sure that you've done problems like this before. So maybe do this one a couple of times if you have to watch how I did that, or if you come up with a different solution, make sure to put that in the comments below so other people can check that. Because I think this is probably going to be the hardest one of this video, unless the next three have some really hard questions in them. I mean, there might be one similar to this. But if you get to this question and you absolutely do not have time to do it, what I would recommend is it's probably, if it says which of the following could be the value of a plus b plus c, it's probably restricted by just a greater than or just a less than, right? And think about it, if it's b squared minus 4ac, it's probably going to be a greater than. So you could go, it's going to be the biggest number. But either way, it would be either a or d. Like you could quickly go, it's not going to be b and c, because it's probably not like x is, or something is less than x is less than something. I mean, it could be. There are problems that shows up. But if you get this type of problem, it's probably coming from, like the restriction on what's meaning it could or could not be that number is the b squared minus 4ac is greater than 0. Or if they say how many times would it have 0 roots, then that would have to be less than 0. So from there, you could figure out it's probably going to be either the smallest or the biggest of these, because the other ones are either too small or too big. In this case, the other ones were too small, they're too negative. And then from there, you can figure it out. So that's a trick, which you could go from having a 1 in 4 chance of guessing it right. Like if the clock is winding down to having a 50-50 shot, it's going to be either A or D there. And then, maybe that could even give you a hint of, all right, well, it's asking for 2 solutions, so it's greater than. And then, I mean, there would be a way where A being greater than 0 would result in a more negative answer, right? If this was like negative 64A, so that's still not a guarantee. But, that could maybe give you an extra edge of, oh, well, it's 2 solutions, so it's probably the greatest of the answers. Or if it's saying how many ways, or what way would you get 0 solutions to make that less than, okay? And if it was 1 solution, then you could just set this equal to 0 and there'd be another equation. It would actually be solvable, right? There'd be one answer. I'm just going to quickly check. So 42, 43, looks different, 44. Yeah, so none of them are that same concept that are in this video. I hope that there's another one of those, maybe between 45 and 66 or 67 and 88, just so I'll have, another example of doing it. Otherwise, I'll just make a separate video going over that kind of problem. But, that's a fun problem. But I do assume that will be the hardest one. So if anyone finds a different solution to do it, or a way that they found it using Desmos, make sure, put that in the comments. And, I'll probably look into that a little bit, because I do think if someone's shooting for a 1600, they probably want to make sure they know how to do that kind of problem in case it shows up. That would use up a lot of time for people who, if you're getting that one at the end of your set and you're running low, I mean, one of the keys to getting a 1600 is just being able to work quickly. All right, here we have x and px in a table. So x, your inputs and your outputs. The table above gives selected values of a polynomial function p. Based on the values in the table, which of the following must be a factor of p? So I guess if you have p of x is equal to something by factor, meaning what do you have to multiply to get p? And I guess the way that you could do that is knowing when the output is 0. So p of x equals 0 when x equals -1 or when x equals 2. So think about, okay, what factor would, when x is -1, you would give you 0 as your product? Well, x plus 1, right? X plus 1, -1 plus 1 is 0. And if you multiply anything by 0, it gives you 0. So x plus 1 would work. Or when would x equals 2 give you 0 for your product? It would be if you're multiplying something by x minus 2, because 2 minus 2 is 0. So x plus 1 times x minus 2. Now, this is a polynomial. It doesn't say it's a quadratic. So there could be other factors, right? This is not giving you all of the zeros necessarily, but those 2 are zeros. And, oh, that's the answer. I was thinking that it was just going to have one of them. You had to choose which one. But x plus 1, or the quantity x plus 1 times the quantity x minus 2. Those would both have to be factors separately. And if you multiply them together, that's also a factor, right? Think about, say you had like 24, that's 4 times 6, which is 2 times 2 and 2 times 3. So you could say, all right, 2 and 3 are both factors, but also 2 times 3, 6 is a factor, like that. So in this case, this is a factor and this is a factor. If you multiply them together, this is also a factor, like the product of them. When the quadratic function f is graphed in the xy plane, where y equals f of x, its vertex is -3, 6. One of the x-intercepts of the graph is -17/4, 0. What is the other x-intercept of the graph? Okay, so the x-intercept is when y is equal to 0. They give us one of those. The vertex is -3, 6, which means the axis of symmetry is when x is equal to -3. And you can try to use that to find what, that's equal to -b over 2a. But what I'm going to do is just, all right, well, if our axis of symmetry is -3, so 1, 2, 3 to the left of the y-axis, right, like that. This is a quadratic, right? It's a quadratic function. So if we have -17/4, which, let's see, -3 is -12/4. That's -3 times 4. So this is -12/4. So -17/4 would be 5/4 to the left of it, right? Like here. So here's one of your zeros. The other zero should be 5/4 to the right of that. So 5/4 more than -12/4, which is -3. So plus 5/4, -12/4 plus 5/4 gives us -7/4. So -7/4, 0. So this solution that I did is just using the fact that the axis of symmetry passes through the vertex, so -3, 6. It doesn't even matter that it's 6, right? It could have been -20. It'd be the same thing. It's symmetrical, so it's going to be the same distance from the x-coordinate of that vertex, which is the axis of symmetry. Right, so it's equidistant from that. That would be how I would do that one. There's probably other solutions, but I think that's the easiest way that I'm seeing. All right, and this is question 44, so it's the last question of this video. Note that there are 88 total nonlinear function advanced math questions that are 3 out of 3 difficulty. So hopefully I'll get those additional 44, the next 44 up pretty soon. But this will be the last one for this video. Function f is a quadratic function where f of -20 equals 0 and f of -4 equals 0. So these are two zeros, -20 and -4. The graph of y equals f of x in the xy plane has a vertex at r, -64. What's the value of r? Okay, this is just the opposite of the previous question where they're giving us the zeros. Right, your zeros are -20 and -4. So we draw this, we got -4 and over here -20. And I mean, it doesn't actually matter, but the y coordinate of the vertex is down really far at -64. But we're just trying to figure out what's the x coordinate of that, which means we're trying to find the axis of symmetry, right? Which is halfway between the two zeros, or really it's halfway between any 2 points on the parabola that have the same y value. These ones happen to have the same y value of 0. So halfway between those would be, well, you think to go from -20 to -4, you have to add 16. So 16 is the length between the whole thing. So half of that would be 8. So you could either add 8 to -20, which give you -12, or subtract 8 from -4, which also give you -12. Or some people like to do the midpoint as the average of the 2 points. So -20 plus -4 over 2. -20 plus -4 is -24. If you divide that by 2, it's -12. So either way, you'll get -12 for that axis of symmetry there, that midpoint. I guess the other way you could do it if you want, you could write like x plus 20 times x plus 4, right, like that, using this. When you know those are your zeros, that would be how you'd write this in factored form. Right? You don't even have to worry about the a value down there. The a value would be what gives you that vertex. But the a value is only going to stretch it or widen it out, but it's not going to change where the axis of symmetry is. Right? The axis of symmetry would just be between those two. So you could type that into Desmos and you would see that your axis of symmetry or your vertex would be at a point where the x value, what we have here as r, is equal to -12. So -12 will be our answer there. That was a fun way to end it. Two problems that were basically just inverted, like they're the inverse of each other, where one of them gave you the vertex, which you used to find the axis of symmetry, and asked for the zeros. This one gave you the zeros and essentially asked for the axis of symmetry or the x-coordinate of the vertex. So, that would be how you do that. This was a really interesting set. I do think this was my favorite problem of it. You could also, I assume for some people it would be their least favorite if you saw it on test day and had not experienced something like it before and didn't give yourself time. But just make sure you pace the test well. Make sure you practice enough that you can work quickly. And I would, hopefully you're watching this, so you've seen at least one time someone do it. But practice this kind of problem on your own. Maybe switch the numbers up a little bit. Instead of 9 coming -14, do something else. You do one where it crosses the x-axis at 0 points instead of 2. So that would mean that this has to be less than 0, something like that. Just, play with that so that you are comfortable with this kind of question. You could see it, set it up quickly. There are a lot of steps, but I mean, we've done questions that have more steps in other videos for, simpler problems. So just as long as you know what you're doing, it'll be doable. And when in doubt, like I had never done a problem exactly like this before. And I do think that you just have to have an attitude of, well, for one, make sure that you're not wasting too much time on it, right? So make sure you've done everything else first. If you get to this, like, I have no idea how to do this, maybe you played around with it for a while, just make note of it so you can go back to it. Do the ones that you know how to do. Always do the problems that you can do first, especially if there's heavy time pressure. When you get back to it, though, and you have time to think, just go, okay, what equations do I know? What can I work through? And you can see I wrote out some equations I didn't end up using. I wrote out, this is the axis of symmetry. I wrote out, this is just plugging in 9 for x, plugging in negative 14 for y, and seeing, does that give me anything that I can work with? Because ultimately, when you have different variables, if you're trying to solve for them or whatever, you need more than one equation in a lot of cases, or in this case, it was one inequality in one equation, and then you play around with it in different ways and try to figure it out. And just think of it like a puzzle, right? Just because you haven't seen a problem like that before doesn't mean you have to freak out. Now, the more you practice, the more you do these problems ahead of time, the less likely you are to be surprised on test day and potentially run out of time. But, just come at it with a positive attitude. I can figure this out. With unlimited time, I know I could figure it out. It's just a matter of, can I figure out this puzzle or this trick in time? And if not, just have some strategies where you can, again, go from a 1 in 4 chance to 1 in 2 chance. Like, all right, well, which could be true. It's probably going to be either the greatest possible one or the smallest possible one. In this case, it was the one that was the greatest because it was b squared minus 4ac is greatest. So that helps you to narrow it down, have a better guessing strategy. All right, so just have that kind of attitude when you're going through it. They did have a decent number of exponential ones on here. They're mostly conceptual. Like none of them seemed that hard as far as the actual math involved. It's just making sure you understand growth factor, decay factor, and are comfortable with those. So really make sure that those are areas of strength for you. This one was interesting. I did like these. I think these are kinds of problems that I might actually use in algebra class. A lot of them were challenging. They had some absolute value ones here. It seems like they like to use absolute value, but it doesn't actually come up that often where the absolute value is the hard conceptual part of it. It's just kind of adding another layer to the questions, making sure that you know what absolute value is. But they haven't had too many where you actually have to solve for a positive and negative answer. I don't think I've seen any yet. But we still have, again, 44 more questions to do. And yeah, a lot of quadratics. Some of these were way easier than others. Some of them you're literally just like plugging in values, multiplying something, finding an area. Like a lot of them I felt like really could have been at least medium questions, and some of them maybe even easy questions. That's kind of the pattern here, where the 3 out of 3 difficulty has some that are actually very difficult, some that are, just have a little bit of a trick in them, but are pretty easy or medium. And yeah, so those were all the questions that we did today. I used Desmos less than I did in the questions 1 through 22, and I'm sure that you could probably find some strategies that maybe would save you some time using Desmos. But, I didn't think that I was overusing algebra on ones that were way easier to use Desmos. I think it was just kind of luck of the draw of what came up. And whenever they put in constants where they don't tell you, then a lot of times it's trying to make it harder to use Desmos. But yeah, if there's a question that you felt like there was a better way to do it, especially if there's something that you think, oh, you could have used Desmos on number 27, or if you can write the question ID, like 271 FFAD 7, you really could have used Desmos and gotten a little bit faster, something like that. Feel free to put that below. If you find any other errors, someone caught one error in my previous nonlinear functions video, so I had to fix that. And it was actually on like the second question. So hopefully I didn't do the same thing here, but if I did, make sure you put that in there. And if you found this video helpful, make sure to like and subscribe. That will promote more videos like this to you and your feed. And it will hopefully also get this video out to other students who are preparing for the SAT. And, again, if you found this helpful, then that would go a long way. So really appreciate that. And besides that, if you're preparing for a test, good luck with that. Good luck with your preparation. Hopefully you crush it on the test. Make sure you go in with the right mindset, go in with good strategies as far as narrowing down your answers, budgeting your time. And thanks for watching. Hope to see you in the next one.